Finding the maximas and minimas is a pretty standard thing now. There's a known algorithm to find them. And it goes as follows. So the algorithm or the recipe is to start with your function, take the derivative, and find the roots of this derivative. So this is precisely what we're going to do right now. So if this is f of x, then f prime of x is equal to minus of, well, the derivative of ln of x is 1 over x, and the derivative of square root of x, well, square root of x is just x to the half, so I can apply the power rule, then I'll get half times x to the half minus 1, so minus half. Or I could just simply write this as 1 over 2 square root of x. Now, taking the derivatives is not really the core focus of this tutorial, so we do not go too deep into why these derivatives are true. But now that we have f prime of x, you would find the roots by setting this f prime of x to be equal to 0. So if you want to find the roots, you just set it to be equal to 0. Then you have some values which you need to compute. So I'll multiply both sides by x times 2 square root of x, assuming that x is not equal to 0. Because if x is equal to 0, then yeah, it's a big problem. And then I get minus 2 square root of x plus x is equal to 0. Then here's what we do. So x will be equal to 2 square root of x, which means that x over square root of x is equal to x to the 1 divided by x to the half is equal to 2. On the other hand, x to the 1 divided by x to the half is just equal to x to the 1 minus half, so it's x to the half as well. And so the square root of x is 2. Now if the square root of x is 2, then maybe I'll even write square root of x. If you want to check this, by the way, you can multiply square root of x both sides up and down, and you actually get square root of x. So as square root of x is equal to 2, then x is probably equal to 4. So now I found the roots, or in that case, these will be the extremas of the function. And this is all monotone, so I'm a bit unhappy about it. My apologies. These are the maximas. No, sorry, my apologies. These are the extremas. And we still need to determine whether this extrema, okay, extrema is a plural word, so it should be just extrema. It's not extremas, but this is not English class, so I hope you can forgive me about this. I'm just making a bit more space. So x is equal to 4 is already an extrema, one of the extrema. It's actually the only extrema, so that is progress. Now there are two ways to find out whether this extrema is a maxima or a minima. First way is to look at the second derivative. So we have this thing called the second derivative test, and it tells us that if you find the second derivative and you plug in your extrema and you get, let's say, a negative value, then your extremum is a maximum, and vice versa. If you plug it in and you get a positive number, then your extremum is a minimum. So it's kind of the opposite. That's a good test. Let's maybe not do that, because this is the first derivative and it doesn't look good if you want to find the second derivative. So my recommendation is that you should do it, but in order to save time, I don't think I will do it because it's a bit ugly. Yeah. But it shouldn't be too difficult. So what is the other way we can do this? Other way we can find out whether the function has a maximum or minimum. Well, the way to find this is by relating the behavior of the derivative, which is f prime, to the behavior of f. We have this very specific theorem which tells us that if the first derivative is negative on an interval, then f is decreasing. And if f prime is increasing, is positive on an interval, then f is increasing. And so we will apply this. Here, we know that f prime is equal to 0. So probably here it's either positive, negative, or negative, positive. We still need to find out. And this is not too difficult to try and find out. So all we need to do is just to plug in a value which is less than 4. So if I plug in a 1, for example, by the way, the least value you can plug in is not 0. It's anything that's positive, because the derivative function is not defined otherwise. So you can plug in anything between 0 and 4, but not 0. Let's say you plug in 1. You get minus 1 over 1 plus 1 over 2 times 1. I don't really care what this will give me. And all I can see that it gives me a half here, it gives me a 1 there. And so 1 minus half, it's minus half. So it's a negative number. So the function is decreasing. That's all I care about, really. And then if I plug in a number which is greater than 4, so let's say I plug in 10, you get minus 1 over 10 plus 1 over 2 square root of 10. Maybe I'll choose another number. Maybe I'll choose square root of 9. So square root of 9 is 3. 2 times 3 is 6. And so this is bigger than minus 1/9. So this is going to be positive. And now to use the theorem which we've been discussing, now the first derivative, this is the analysis of the first derivative. Since it is negative, then f is decreasing on this interval. And vice versa. Since the derivative is increasing on this interval, the derivative is positive on this interval, my apologies, then f is increasing. And intuitively, if you're decreasing and decreasing and decreasing, and then you stop at a point and then you start increasing, then probably this is a minimum. Or one of the minimas. Sure, it's just vocabulary. And it is true. So if you give me a moment, I will now plot the graph of this function so that you believe that what I'm discussing here is not just utter nonsense. Because if you do think that, will be very inconvenient, right? So here I am back with the graph of the function. And this is actually great. So So as we've initially noticed, the function is not defined for negative values and it's not defined for 0. There's probably an asymptote there. Keep zooming in, gets very close to 0, but it never reaches it. But that is not the focus. We would like to know whether 4 is a maxima or a minima. But we can see this now, because if you notice this, so the graph is going downwards. I don't know if you see my pen, and then it kind of shifts at 4 and it starts increasing. Okay, the opposite. It's a bit difficult because my image is mirrored, so I have to do it downwards if I want to go upwards. But what I want to say is, it starts increasing, starting from 4, and goes up and up and up. So I'm glad I was able to redeem myself and show you that this is not untrue. So this is just another way of saying that this is correct. And I'm glad that it is.